In terms of the derivatives of various functions, you need to know that there are many of them. And the way those derivatives are sometimes found require advanced techniques. You may have encountered the derivative of ln of x or e of x, and you would have known it doesn't quite fit what you would expect when you think of the sum rule, for instance. So we are actually talking about it a little bit later on, and I'll come back to that point when we get there. Just want to conclude the sentence. The way those derivatives of these various functions are sometimes found require advanced techniques. So you can expect to get a formula sheet for it. It is not always as easy as the sum rule. So basically what I say with that is, if you are given that f of x is equal to 3x squared, let's say for instance, then you know that the first derivative is simply multiplying the exponent with the number at the front and subtracting 1 from the exponent, so it gives you 6x. That is the derivative of 3x squared using the sum rule. But if you have ln of x, then you have a totally different derivative that you can't explain just with the sum rule. E of x, the derivative of e of x is just e of x. So how do you explain something like that? So it's just important that you know that the way those derivatives are found can be a very cumbersome process, or there might be a totally different mathematical technique to find it, etc., etc. So you can expect to find a formula sheet. That's the point I'm trying to make in that first paragraph. So then, if we take a look at the derivatives of the trigonometric functions, let's just stand still there for a second. The first derivative of sine of x is cos of x. The first derivative of cos of x is minus sine of x. The first derivative of tan of x is sec squared x. Cot, the derivative of cot is minus cosec squared. The derivative of sec of x is sec x times by tan x. And then the derivative of cosec x is minus cosec x times by cot x. So those are all valid. They are the derivatives of the functions on the left-hand side. And in order to remember them might be something that requires doing these things, million of them every day for like a couple of months, and then you will slowly start remembering which one is which one. So you can expect to get a formula sheet, and we'll come back to that. Just hold that thought for a while. I just also want to take a look at the derivatives of the inverse trigonometric functions. Now, when they talk about inverse, they actually call it arc-sin, or arc-cos, or arc-tan. But where it comes from is if you go back to trigonometric equations. So let's say you have something like the sine of theta is equal to 0,5, and you need to find theta. Then typically what you would do in algebra, if you have something like this, 2x is equal to 4, you'll divide by 2 on the left-hand side so that you end up with plus 1x. So you divide whatever is standing in front of the x by itself, and then you will get the plus 1 that you are looking for. And what you do on the one side, you must just do on the other side as well. Now, if we apply that same logic to a trigonometric equation, we're going to divide by sine on the left-hand side, assuming it's going to cancel, and you will divide by sine on the right-hand side. Now, if you try and feed that into your calculator, if you say 0,5 divided by sine, it's going to give you an error. So you need to think of this a different way when you are working on the calculator. And that is to remember that that sign actually has an exponent of 1. And when you bring that up, it will become 0,5 sine to the power of minus 1. But it's not really sine to the power of minus 1. That is sometimes called a shift or a second function key on your calculator. But that is exactly what they are also referring to when they are saying arc sine. It's just the sine to the power of minus 1, or the shift sign, or the second function sign on your calculator, whatever the case might be. But it has its own derivative, and it looks like that. And the same for arc cos, the same for arc tan, and so forth and so forth. So you have this on a formula sheet. You just need to know how to use the formula sheet. That essentially is all that is required. So when we take a look at a typical question that involves this, they give you that g of x is equal to arc tan 3x. And they want to know what the first derivative of this function g will be in the point square root 2 over 3. But we can see, just by virtue of them asking for the first derivative, And you know that they're asking for the first derivative because of that. So you know you need to find the first derivative of g of x. So what we will do is to take a look at that. Now just the arctan means we can go back and say, okay, arctan is there. There we have the first derivative of arctan x is 1 over x squared. However, there is not an x there. There's a 3x. So you should immediately see the chain rule there because of that 3x rather than just x. Because going back to the formula sheet, you'll see that there's just an x there and the x then appears in the first derivative. If you have something that is more than just x, such in this case 3 times by x, it means it's a function inside a function, and you will then apply the chain rule. So let's make the variable u equal to 3x. So we just replace that 3x with u so that we now have a simple function for which we need to find the derivative. So now we have arctan u, and again, according to that formula, 1 over 1 plus x squared, the first derivative will now just become 1 over 1 plus u squared. All right, so that is the first derivative of the arctan u. Now we know that we need to use the chain rule because of the function inside the function, and this is just a nice way to remember the chain rule. The first derivative of the outer part multiplied by the first derivative of the inner part, and we can say that the outer part is that arctan u, so we know that is the first derivative. We already found it up there, and the inner is that 3x that we replaced or made the u equal to. So now we can say that 3x, let's find the derivative of the 3x, and that's the normal sum rule. So you multiply that exponent with the number at the front, so 1 times 3 is 3, then you subtract 1 from the exponent, it becomes x to the power of 0, which is just 1, so it becomes 3 times by 1, or then just 3. So the first derivative of the inner part, that 3x, is just 3, basic school calculus first derivative, but we multiply those two derivatives, the outer and the inner, or the inner and the outer, actually, we multiply them, so that is the 1 over 1 plus u squared, where I've just replaced the u now with the 3x. Because remember we said that. We said let's make u equal to 3x. So all I did was to take that u there and replace it with the 3x there, multiplied by the first derivative of the inner part, and then just basically normal algebraic fractions. So it gives us 3 over 1 plus 9x squared. Now the original question said we need to find the value of this first derivative in that point, square root 2 over 3. So we'll just evaluate at x is equal to square root 2 over 3. That's all we do. Replace that x there with square root 2 over 3. And again, it's just normal algebraic fractions. So replace it there. The square of square root 2 just becomes 2. And the square of 3 becomes 9. Then that 9 and that 9 will cancel out, and we'll be left with 3 above and 1 plus 2 below the line, because remember the 9's cancel, so it's 1 plus 2 below the line, which will give us 3 over 3, or then 1. So the answer to this question really is just 1. So that original question that we started with is just 1.